Well, hello everyone, Colin Archibald here. I've for some time wanted to start talking about methods and classes and object-oriented stuff. And I'm going to put it in here in the sequence of videos, not so that you become an expert in all of this, but to get an introduction to it and start to become more comfortable with what's going on, what's to come. What we've done up until now in these videos is we have looked at just about everything we can do inside of one method. So inside of the main method we declared variables and we used operators, control structures, so if statements, selection structures, and loop structures. And now we're going to have to eventually do things outside of one method. Let's start thinking about that. I want you to also start getting more comfortable in Eclipse, and if you type SYSO control space, you'll get this system out print line. And in fact, in Eclipse, control space is the what are my options right now, like the can you suggest anything. So I want this to a very simple program just to start typing some demo things and make sure that we have this running. Okay, so we have a program that runs and outputs hello. Let's make this a little bit bigger. So inside of this method, what have we been doing? We've been doing things like declaring variables of primitive data types. So double variable like that, and we can put things in it. So I want to tell you that there is a bunch of stuff that's already been done for you, and these are sitting around in classes. So Java is a pure object-oriented language, which means a bunch of things, but one of the things it means is we cannot call methods without it being as part of a class. So methods are declared inside of a class. The method that we've declared so far is the main method, and it's inside of this class, which I've called demo OOP methods terminology. Class names always start with a capital letter, and variables always start with a lowercase letter. You have to do that. No one will be able to read your code, including you, as soon as we get working with a lot of classes and variables and objects. So one of the classes that's really common is the math class, and it provides for you a bunch of methods. Some of them are familiar to you. So let's take the square root of something. And while we're typing, you see things popping up that are the things that are suggested. What is the square root of 100? And it's a double, so I'll make it 100.0. Well, this is a method call. So the method is called sqrt, and you can pass something into the method. So think of this as we want to take the square root of 100. And we can't call a method unless it is part of a class, and this is the name of the class that we're accessing. So the math class has a bunch of methods in it. One of them is to take the square root, and it returns a double value, and we can put that into a variable. So this method call, this whole thing right here, whoops, evaluates to the value that is returned from this method. So the square root of 100 is returned from that method, and we say that this part that's highlighted evaluates to what is returned. So let's print out and concatenate in the variable. Okay, let's keep running this to make sure that what we're doing is what we expect. So the square root of 100 is 10.0. Okay, so this evaluates to a double, and you can use that as with any other double in an expression. So this is a double added to another double, 45.6. I'm not sure why. I just wanted to show you that. Think of this method call that returns some value as just that value in the rest of an expression. So the square root of 100 plus 45.6 goes into there. Make sure that things still run every once in a while. Of course, the comment now doesn't make any sense. That's not the square root of 100. The square root of 100 plus 45.6. There, does that make you feel better? Okay. When we're typing, you might see that things are popping up like documentation. And so here's the math class. The documentation for the math class pops up. And it gets away. So let's highlight the name of the class and select Shift F2. Okay, Shift F2 is opening a web browser. And this is giving us the documentation for the math class, which is available to all of us to use. And the math class is composed of almost all methods. So here is a whole bunch of methods. And two constants. One of them is pi, and one of them is e. So if you need to like raise something to the power of something else, here's a method to do that. So the power of a to the b. And how will we know exactly what that does? What data types we have to pass to it? What data types it returns? If you click on these, wow, it will tell us in a lot of detail there what's going on with this method. In fact, this is all of the documentation for the POW method. Let's go and try it. Whoops. POW 2, 3. Two to the third power. Oh, well, we can't call that method without naming the class. I just told you that a minute ago and then I didn't do it. Okay, math.pow 2 to the 3. Let's run this stuff. 2 to the third power is 8.0. And the POW method deals with doubles, so really it would be a little bit more correct if we put. And you can play with these. And now as soon as you play with these once, you get them in your repertoire. What is 10 to the power of 32? Oh, look at that. We get the double represented in scientific notation. That's 1E32, or 1 with 32 zeros. Does that make sense to you? Good. Okay, so finding out what methods are available to us. The documentation is right here. There isn't any going looking for a book and turning all of the pages. What is the value of pi? Okay, I don't know how many places of accuracy it's showing there. A double usually has 15 places of accuracy. 3, 6, 9, 12, 15. There's 16 places of accuracy, so I suspect that that one at the end might be wrong. It might have a rounding error. So all of that's a constant, and you can tell it's a constant because it doesn't have parentheses. you can tell that this is a method call because it does have parentheses. So we're saying the square root of 100, and that method call evaluates to something. And you can tell what it evaluates to by the return type. So there's all of your trigonometry things, your cosine, and here's Euler's number raised to the e. E raised to a power, and the logarithms, natural logarithms. Max and min are really simple. Return the greater of two floats, return the greater of two ints. So, we have a whole bunch of stuff now that you can take advantage of in the math class. And there's nothing special you have to do, just be able to find the documentation to figure out what is available to you, what math is available to you. So these methods that we're calling from the name of a class, those are static methods. And there's a difference between a static method and a dynamic method. So let's look at another class, and we've seen some of these. Okay, so now here's a variable, and its data type is string. Its data type is the name of a class. So we have a variable, a new kind of variable. Now it's a reference variable. It references an object of type string. So when we want to make an object, we use the keyword new, and you get used to these. You can make an object in by calling the constructor method and passing whatever the constructor method needs. And now we have an object of type name. I think we've probably done one of these already by using the scanner class. We made an object of type scanner so that we could get some input from the user. So what can we do with this name variable? Suppose I wanted the length of that string. I'm going to say name dot and see what pops up. Oh look, one of the things that pops up is length. When you have the one highlighted that you want, you can just hit enter and it will type the rest of it for you. Okay, so what is the length of that string name? It's going to be 5. Oops. Okay, len has 5. Let's distinguish these two kinds of calling of methods. We looked at the math.squareRoot method, and we pointed out that we are calling the square root method from the name of a class. It has a capital letter, so it must be the name of a class. That method belongs to the class. And when we look at the documentation for it, when it pops up, you get this little red S. It stands for static, and that means that this method belongs to the math class. Here's another method, the length method, and it belongs to an object. So an object of type string has a method called length. We're asking for the length of this particular string. So the length of string known as name will return an int. Here's the return data type. And this is not a static method. So when you see the signature of the method in the documentation, public int length, public means we can see it from anywhere. Int means it will evaluate to an int. And length is its name. So because it's not static, it must be called from an object. In this case, it's an object of type string. The square root method is a static method. it belongs to the class math. Okay, so what are all of the things we can do with a string object once we have one? So this is the construction of a string object. Well, let's look at the documentation for the string class. Shift F2. Shift F2 will bring up the documentation for the string class. Some of this will be really confusing for now, but there are some that really make sense. Character at index. What is the character at this particular position? Well, let's try it. No, I don't want an int, for goodness sake. Just say char. What character is at name dot char at 2? Oh, it's an L. C-O-L. Okay, the first position in the string is position 0. Then the O is at position 1. And the L is at position 2. The I is at position 3. Okay, so all of those things that you can do with a string. You can find its length. You can split it. You can take a substring. You can take a substring from here to here. And if you want to look at the contents, the contents of the documentation for this method, you click on it and you find out exactly what's going on. And as you get better at this, you get faster at reading the documentation. Okay, so a static method belongs to a class. A dynamic method belongs to an object. I make a big deal out of trying to make your code readable. Your variable name should be correctly spelled English words. Len is not a good word. So suppose I have a variable name and I decide I don't like the name of it, but I've used it a bunch of times and I don't really want to put the effort into going all around and changing it. This is called refactoring. So I'm going to highlight the variable, refactor, and then rename. I'm going to type a new variable name and then hit enter. And it will run around and change all of them. So you notice that it changed this one here, and that was the only place that we used that variable name. I don't really like too much when people do their arithmetic inside of output statements. So I kind of regret doing this example. Each line of code should do only one thing. So doing this calculation as part of the output statement is really frowned upon. I mean, it saves a line of code and maybe it saves a variable, but we probably shouldn't have done that. Why? I hope you're using the debugger by now. So, right-click out here and turn on, well, we can turn on some things. Let's show, we have line numbers turned on. Let's turn on a breakpoint on this line. Now when you want to run this program, click on the bug instead of the play button, and it should switch to the debug perspective. If it's the first time you've done this, it might ask you if you're okay with doing that, and you should always say yes. I have some Android stuff going on in there. Okay, so hover over the variables. When we're in the debugger, the arrow that's being, the line that's being pointed at by the arrow is the line of code that has not yet executed. So let's execute them. Memorize these keys. Step over means execute one line of code. Use the F6 key instead of that button. So if you hold your finger on the F6 key, now we can watch the code execute, and we don't have to move the mouse up here and back down here and all of that. So we're going to execute this one line of code at a time. Make sure that what's coming out on the console makes sense to you, that the value of the variables makes sense to you. So this variable has the value 55.6. We didn't have to print it out. We could have just used the debugger to hover over it and make sure that every line of code is doing what we want. In your assignments coming up, you will, as you develop your skills in writing algorithms, you will need the debugger all the time. So get used to working in here. See the variables as they change as you execute lines of code using F6 in Eclipse. So what's in character? My car, it's an I, and print it out. If you get tired of the debugger, if you see what you've done wrong, you want to go back to change the code, you can always stop the debugger using the terminate and switch back to the Java perspective up here on the upper right. You probably don't have a DDMS and an SVN. You have a debug and a Java perspective. You can go back and forth between those perspectives. So most of the time we would be editing code in the Java perspective, and when we're running in the debugger by using the bug and F6, we stepped past the end of the program, and now we have a thing that looks like an error message, but you can just throw those away and kill it using the red box if that makes sense to you, and get comfortable in Eclipse so that the brain power that you have is applied to solving the problem that you have at hand, as opposed to trying to remember how to do something with the tools. So the more time you spend in here effectively is the how good you are at it, and how good you are at it depends on how easy the problem solving will be. Okay, so in here, what did we achieve? We haven't created any methods yet. That's coming up in a later video. But we've started to call methods. Methods that belong to a class are static. A class name always has a capital letter at the beginning. And methods that belong to objects. So this object of type string has methods associated with it. Methods that belong to classes are static methods, and methods that belong to objects are not static. They are dynamic, but there is no keyword dynamic. There is a keyword static. Okay, so this is kind of a heads up for what's coming up, and getting comfortable with what we can do, adding stuff to your repertoire. Look at all the stuff you can do now with the math class that you couldn't do just an hour ago. And all of the things you can do to manipulate strings that you couldn't do just an hour ago. And it's up to you to go and read the documentation for these methods so that you can achieve what you need to achieve. And that gets faster as we go along. We looked at 2 classes. In Java there are about 6,000 classes. You won't know all of them. No one knows all of them. No one knows all of the methods in all of the classes. The only way we can work in this environment is if we have our Javadocs very, very close to where we're writing the code. Shift F2 will give you the Javadocs, the documentation for the string class. Very good. I hope you're having fun with this. I'll see you next time.